Humanity's search for extraterrestrial life has historically pointed toward the red, wind-swept deserts of our immediate planetary neighbors. But the most promising conditions for biology are actually 1.2 billion kilometers away, in the orbit of Saturn. The target is Enceladus, a moon so small that it would comfortably fit between the borders of Delhi and Mumbai. Despite its frozen surface resting at -200 degrees Celsius, this tiny rock is actively shooting massive geysers of water hundreds of kilometers into space. These plumes prove that Enceladus is a dynamic world hiding a secret pressurized ocean, a discovery that changed the focus of modern astrobiology. In 2025 and 2026, a series of data reanalyses and laboratory experiments produced results that caught the scientific community off guard. Based on the new evidence, scientists officially upgraded the moon's classification from potentially habitable to fully habitable. To sustain life in the freezing vacuum, a world requires 3 specific ingredients: liquid water, a steady source of energy, and complex chemistry. Enceladus has become the first alien world to systematically satisfy every variable required for this classification. This raises a fundamental question of physics. How does a tiny moon billions of miles from the sun maintain a liquid ocean without freezing solid? The answer is tidal heating. Saturn's immense gravity physically stretches and squishes Enceladus, creating intense internal friction that generates heat. For years, researchers assumed this friction only heated the southern pole, where the geysers are located. However, data released in 2025 shows the northern pole is 60 degrees hotter than expected, confirming that the internal heat and the ocean itself are global. Calculations now show that the amount of heat generated inside the moon perfectly matches the amount escaping from its surface. This thermal equilibrium allows a liquid ocean to remain stable for millions of years, providing the time required for biology to develop. Water and heat are only the beginning. Life also requires complex, carbon-based building blocks to assemble itself. As the Cassini spacecraft passed through the geysers, it captured fresh ice particles straight from the source before they could be broken down by space radiation. Analysis of these pristine samples in 2025 revealed advanced organic compounds with carbon atoms bonded to nitrogen and oxygen. Crucially, the samples contained amines, the direct precursors needed to build amino acids and the proteins that drive all known biological functions. Enceladus is actively brewing the exact chemical precursors required to build and sustain biological organisms. Some skeptics argued these chemicals were simply created on the surface when radiation hit the ice. To settle the debate, 2026 laboratory experiments simulated the dark, high-pressure environment of the Enceladus seafloor. The results showed that these complex organics can spontaneously self-assemble using only water, internal heat, and basic minerals. Enceladus possesses a chemically active, self-sustaining underwater engine that functions entirely without sunlight. With water, heat, and chemistry confirmed, the focus has shifted to whether an active ecosystem exists there right now. Any potential life would likely consist of single-celled microbes living in total crushing darkness. This environment mirrors Earth's deep ocean floors, where organisms survive solely on the chemical energy released by hydrothermal vents. Finding life that thrives on chemical energy alone would redefine the known limits of biology across the universe. Exploring Enceladus does not require us to invent massive drills to pierce miles of thick ice. It is the only world in the solar system that is throwing samples of its ocean into space for us to collect for free. Space agencies are now planning missions for the next 10 to 15 years to fly through these plumes and hunt for definitive evidence of living organisms. If these upcoming missions find microbes in the orbit of Saturn, it will confirm that life is a common occurrence in our universe.